Alright guys, welcome to the first lesson of our next unit of study in Calculus AB. We're going to start out by understanding the definition of the derivative at a point. Alright, and so there are three goals that I want you to accomplish in this lesson. The first goal is to be able to list the three representation of a derivative. So you're going to be hearing the word or the term derivative a lot throughout this unit. Recognize when a limit represents a derivative. And finally, find the derivative of a linear function analytically and graphically. Now, this is the basic foundation of our unit, so it is important that you understand this lesson clearly, and if you need to, you can rewatch the lesson a few more times, and I guarantee you that every time you do, you will pick up something that you didn't pick up the first time. Okay, now we are entering one of the two main branches of calculus. So this branch is considered differential calculus. Alright, so the big question that you have been waiting for is, what is a derivative? Okay. Well, when you hear the word derivative, I want three things to immediately come to your mind. First of all, the derivative is the limit of a difference quotient. I'm going to talk about this a little bit later too, so that you understand what it means by difference quotient. The derivative represents instantaneous rate of change. Instantaneous rate of change. Now you might wonder, what the heck is that? Well, here's a very simple example. If you look at your speedometer in your car, and let's say it reads 45 miles an hour, at that instant, that's called the instantaneous rate of change. Okay? And the last thing I want you to think of when you hear the word derivative is, it is also the slope of the tangent line at that point. Remember that a tangent line is a line that touches the graph at exactly a point. Okay, so that's a tangent line. Now, let's go on to first understand the tangent line, and then I will eventually show you how to find the derivative. A tangent line to a point on a curve is a straight line that only touches the curve at a single point. I wrote that here earlier. So when we're finding the derivative, guys, of a curve, we are trying to find the slope that touches, we're trying to find the slope of a line that touches the curve at just a single point. Before I continue on, I'll draw you guys a quick example here. Let's say if this was your curve, right? And let's say if I want to find the tangent line at that point right there, then basically what I'm looking for here is, I'm looking for the slope. Okay, I'm not looking for this line. I'm looking for what would the slope of the line that touches the graph at a point. Now remember, the slope is kind of like the measurement of the incline, so how much incline it has, and that's the slope. Think of the slope as running on a treadmill. When you're running on a flat surface, then it has a slope of 0, right? And as you increase the level of incline, then you know that the unit of increments goes up, so the slope increases. That's the slope. Okay, so in order for us to get to the tangent line, what we have to do is we kind of have to start off by choosing like any 2 points on the curve, like that, and then we connect these 2 points with a line segment. Okay, and what we want to do is we want to somehow continually to pick the second point. This is the first point, this is the second point. We're going to pick the second point closer and closer and closer and closer and closer to the first point. And the more we do that, as you can see, this line will get, this line right here, see, it will kind of get closer and closer and closer and closer to our tangent line. Remember that the tangent line is a line that touches the curve at just one point. So the closer the second point is to the first point, the closer that secant, those set of secant lines will get closer and closer to what we want, which is the tangent line. All right, so that's really cool. That's really cool. So you start off with your first point, and then you choose another point, and then you try to just keep the distance between the first point and the second point as close as possible. So close, and it's hard to understand this, but you keep the second point so close to the first point that you cannot see it with your naked eye. Even with a magnifying glass, you might not be able to see it, but there is a gap. Okay, that's the beauty about differential calculus, guys. All right, so if you somehow can pick the second point so close to the first point that they become almost identical, then you get what we call the tangent line. And when I say almost identical, it is so close that it's actually identical. All right, which is kind of hard to understand, but it's okay. You guys will get better because you guys are very smart, so keep that in mind. Okay, all right, so our goal is to compute the slope of the tangent line, which is this guy. Okay, all right, let's say if we want to find the slope of the secant line, then we would go like this, guys. We would go, the slope of the secant line is really the change in the f function. This is the f function, also known as the y value, over the change in the x value. Okay, now the change in the f function given these 2 points can also be expressed as the second point is known as f of x. This is the change in the y value, okay? And the first point is known as f of a, so the change in y over the change in x, and the change in x is x minus a. Okay? So our goal here is to compute the slope of the tangent line. So what we're going to do here is we are going to drive this x value somewhere out here, guys, really close to a. All right, so we are gonna, the slope of the tangent line is, we're gonna take this function, and we are going to drive that x value. We're going to drive that x value really close to a. See? And guess what? You've seen this expression before. All right? And that's how we're going to be able to achieve. What are we trying to achieve here? Well, we are trying to achieve the slope of the tangent line at that point. All right? And the slope is like the level of incline, and that's a number. Okay? Keep that in mind. Awesome, guys. What's the next part? And then we're going to continue with this cool concept of derivative at a point.